So welcome back to Newcastle Central. It has been another delay between last set of videos. I have been having quite an adventure with the point motors, that I've been putting in place. I'm going to kind of save that for the next video. I've got some clips going along. I'm just waiting on some more parts. It's been not delay after delay, but it's been an awful lot of trial and error, trying to figure out exactly what parts I need to get those new point motors fitted from Tam Valley Depot. Not really any knock on those point motors and the controller and DCC controller. I've just kind of taken a much different route than I had originally thought of when I got into that project. So I've got half of the point motors fitted that I need, and I've been doing an awful lot of planning in something else. I'm trying not to give too much away. Still kind of work in progress. But while I've been waiting for parts to show up and different pieces of wiring, different push buttons and whatever else to show up to try and get that going, I also went and took a little bit of a break and started getting into some 3D printing on signal gantries. So this is something I've been wanting to do for a while. I did a video of 6-7+ months ago now. I started playing around with one of the Transect Signal kits to figure out how to hook that up into an Arduino with some sensors. I then did a video before Christmas where I then prototyped doing an overhead signal gantry, and I kind of had that going. I had the lights upside down. I think I had red on top of green, like traffic signals, and I wasn't super happy with how the cabling then worked. And just in general, I've been trying to figure out, okay, how can I best do this for Newcastle Central? Newcastle Central, I couldn't find anything that matched the prototype. I'll try and put a picture on the screen now as to what I feel the signal gantries I was wanting to put on the layout. A lot of the ones that I could find were much more just, it was on a pole and then a 2 or 3 or 4 aspect signal head. I really wanted to have the theater route indicators as well, and I couldn't find just a very basic model of what one of those would be. I could only find ones that were like 15-20 pounds that included LEDs and would actually display an actual route, and it's like that was getting a little bit too much. So what I've had in my mind for a while was somewhere to design and then build these, and I ended up playing with 3D printers for some flight simulator stuff that I'm doing anyway. Got a couple of different projects going on at the moment, and so 3D printing allowed me to very, very quickly prototype this, design it out, get it ready. And so rather than trying to do something scratch built from styrene or wood or whatever, and then say, okay, great, I've got one of these, but now I've then got to go and cut the parts again and again and again, because I need to have probably 20 plus of these all around Newcastle Central. I can design it out one time, get it ready, and then say, great, now go and print me 20 of these, and it will be 20 exact replicas, the exact same dimensions, the exact same sizes in terms of how they'll go together and things like that. We're not having to cut and measure and end up with 20 ever so slightly different signals. So let's go on a little bit of a tour. I'm still pretty new to 3D printing in terms of how you do the actual 3D design on the computer and how you then go ahead and print that and assemble that. But wanted to share where I'm at, what I'm up to, share out the actual 3D model itself if other people want to try it out, and so we can kind of start to make some progress on signaling here, at least on the south side of Newcastle Central. Okay, so this is then on the computer with the 3D model that I had put together. This is actually in an application called Cura, which is kind of the final step when it then comes to how you would actually go ahead and print all of this out. So I designed the 3D model itself in Tinkercad by AutoCAD, which is kind of one of the big professional pieces of software, but they have an online tooling called Tinkercad, which is really, really easy to get up and running. I have tried some of the other desktop applications like Fusion 360, and there's a Microsoft 3D Builder and things like that, but I found Tinkercad was really good just to quickly start to put this together and test it out. I'm by no means an expert on this. I've just been doing this for a week or two, so this is the first real thing that I've completely designed from scratch. But you end up with this 3D model that you then import into Cura. There's other applications that can do it. This is just what I went with. And then settings wise, you can choose kind of what resolution you want to print at. So I'm at fine 0.1 millimeter. These settings are then mostly all the defaults out of the application. Infill is 30%, which is how much material to do on the inside. Doesn't make that much of a difference here. I then found through trial and error with my particular 3D printer, temperature of the actual material of 200 degrees Celsius, and then the actual bed, and we'll look at the 3D printer in this next clip. I can also then heat the bed, and then I did what's called a raft, which then puts an area all the way around this, just so that it adds a little bit of adhesion, but also then makes it a little bit easier with these fine railings. And so we would go ahead and do what's called slice, and slices just take my 3D model and then layer by layer figure out how you would build it up when you send that off to the 3D printer. And so what you can see is this is what these layers would look like. Looks a little bit funny, but all of this kind of yellow honeycomb stuff around the outside, that's that raft that gets added, and we'll see what that looks like when we print. Now, one thing that we could do here, this is an example of the 3D model that I've uploaded to a site called Thingiverse, which is an online website that lets people upload different models. You can then download them, or you can remix and make some edits. Essentially, it's just a place to share out 3D models for others to download. So the model that I've uploaded just includes one of these. What I actually would do is go ahead and duplicate this, and I would do something like 3 at a time, maybe. And then, I would probably rotate these so that I get them as close together and minimize the waste. But you can print as many of these as you want, depending on the size of your bed. I could probably, as I guess, do 6 maybe at a stretch on my printer, but I think I've just been limiting it to 3 just to make sure that it stays right in the middle of that print bed. I don't get too close to the edges or anything like that. The file itself comes with 1. You can print as many as you want, and so once you would have that file, it's gone ahead and sliced it. We can then save the file and send it over to the 3D printer. So let's now go and kind of have a look at the printer I've got and what it starts to look like. If you've never seen a 3D printer, it's kind of cool. Maybe this isn't the most exciting of models because it's all fairly flat, other than the theater out indicator right there. But it is pretty cool when you start to see things that end up 2, 3, 4, 5 inches tall, and just to see how a 3D printer comes together and starts to do the additive part of building up the model. So this is the 3D printer that I'm using. The fans are running on it, so hopefully it's not overly loud. But it's the Creality Ender 3. I've spent well over 2 years wanting a 3D printer, kind of on and off researching them, and it kind of has reached the point now, I feel, where the quality of the printers, the prints that they can produce, and then lined up with the price points, there's really an awful lot of options that are available. So this is the one that I ended up going with, like I say, after an awful lot of research. You could go a lot of different directions here, so this isn't necessarily a specific endorsement, but there's an awful lot of positive videos on YouTube about this and some modifications that you can do. So this has already got quite a few modifications. There's a webcam holder. I'm using a Raspberry Pi to control it. There's a cooler shroud underneath there. There's a spool feeder, things like that. So if you haven't seen a 3D printer before, they're actually really cool. We'll run through and get to see a little print going on this, but essentially you have a spool of filament. I'm using PLA filament, 1.75 millimeters. It feeds into what's called an extruder. Right here, if we come underneath, I could probably do with cleaning a little bit, if we can focus in. There's a metal brass extruder right in the middle. That's kind of hard to focus with the light. And what happens is that will start to heat up the filament and then squeeze it out in very, very fine line. I think it's about a 0.4 millimeter extruder. And so it's on 3 axes, so it can move left and right, up and down, and then this whole plate could move around as well, kind of like that. So the idea is that this extruder will come all the way down the bottom, and you'll see it kind of zip around and move around, almost like if you've seen a CNC machine, some kind of cutting machine, very similar to that. So you can take the designs that we looked at on the computer, you run it through a program that essentially slices it into those individual layers, very, very fine layers, and then it sends it off to a 3D printer like this, and it goes ahead and prints them. So this is, very much whirlwind. I'm not really getting an awful lot of depth. I've only had this for a couple of weeks, so I'm by no means an expert. If you are wanting to know more about 3D printers, I definitely recommend that you go and look at some of the videos on YouTube. Like I said, specifically the Creality Ender 3 is the one that I went with. This was about $220 US. That's I don't know, £160 in the UK maybe. So prices may vary, but I feel at least that now they're at the point where there's some pretty good quality 3D printers that you can pick up that produce the kind of results that you can see in that signal mask that we had on the layout. So I'll start up a print here so we can start to see it going through and get a little bit of a better idea how the process actually works. Okay, so this is now the print job started up, and you can see as the bed moves around, if we come in close, maybe just about see some of the filament coming out. There we go. And this part doesn't need to be perfect, just to try and explain what's happening here if it looks like a whole bunch of squiggly lines. What we want to end up with is I'm printing 3 sets of these gantries. This is what each of the individual components look like. And because these are, they're not super delicate once they're printed, about 1 millimeter diameter all the way around those edging pieces, but they are a little bit fiddly when they're adhering to the print bed, and they can easily warp and get twisted up because they're so thin. So what we have doing over here is it's printing what's called a raft. And a raft, it's maybe a little bit wasteful in terms of the filament, because it's, you know, it's then going to go ahead and do a crisscross pattern, then it's going to go do a diagonal pattern. But essentially what it's doing is it's laying down a bed of the filament so that it gives it something to adhere to, so that when it starts to print those fine pieces like the guardrails or things like the step ladders that would lead up to the signal gantry, they're not sticking directly onto the bed. The filament isn't trying to adhere directly to the bed. And it's not really a problem with bed adhesion, which can be an issue with 3D printers. This is a legitimate method of being able to attach it. You can do a raft, you can do a brim, which is where you kind of go right just around the mold to raise it up ever so slightly. You can also do a skirt, where essentially it would just do the outline of it, just to make sure you get the filament going. Just through trial and error, I've found that the best way to try and do this is by printing out a raft. So it looks a little awkward because there's squiggles everywhere, but there are 3 sets, and they kind of rotate it around to minimize the amount of waste that's going to go on here. There you can see it's just kind of moving its way around, filling it in. Not super exciting right now, but I can monitor all of this through my phone, so I can keep track of the status of it. I don't have it set up to control intentionally, so just so that there's not a problem if someone were to try and hack into this or anything like that. All they're going to be able to do is watch that pretty little webcam stream. But I'm going to head out of the trench shed. This will take about an hour and a half, maybe a little bit longer, hour 45 minutes maybe in total to print 3 sets of the signal gantries. But we'll come back in, I don't know, 30-40 minutes or so, when it should be starting to actually print out the gantry parts themselves, and you can see how they get developed. Yes, I'm back out into the trench shed while that print job goes through, completes that last set of signal gantries that I need. But I wanted to kind of talk through this idea of just, you know, how almost earth-shattering it's been with a 3D printer in terms of what's called rapid prototyping. So the idea is that you have an idea in your head, you have a plan, some kind of vision inside of your head as to how you want something to look, but you're not entirely sure, you know, how it's going to turn out. And so you can draw it out, of course, and you can do things with styrene and strips of plastic and things like that, but 3D printing really kind of has completely changed how I approach this, and it's one of the reasons why progress has been kind of slow on Newcastle Central. I kind of gotten to a point where I needed to do an awful lot of signaling. I need to do an awful lot around things like station platform for the roofing and for the support mounts and pillars, platform pillars, things like that. So aside from 3D printing, I've been doing a lot with laser cutters at work, kind of learning how to do that and doing some different things. So I expect more there. But this is the idea of rapid prototyping. So this was the very first idea that I made, you know, and so you can see it's not great. It didn't really adhere. Probably it's probably a little bit on the small side, and then you had the platform itself, and like I said, it was probably a little bit on the small side. So I then stepped it up a little bit and went to this side, and this started to adhere a little bit better. And I was like, okay, well that's cool. Now I need a way to lock it in. So then I started to put in right there on the edging, you know, little supports where it will be able to notch into place. And then I kind of just refined that a little bit and got it to the print level that I wanted to. I think that was when I then switched to using rafts. And so that turned out pretty good, and so I ended up with this original run. And you can see I've also fitted one of the signal heads that I'm using, and I've also done a theater indicator. just next, just to the left of the signal head there. So I'm not expecting those to be lighted up, but I did design that out as well, which is one thing that I was kind of missing. Newcastle Central has these everywhere, and this is kind of one of the problems that I had. So some of the things like the Transect signals that I've used, they look really, really good, but they're not prototypical for all the photos that I've seen from what I can remember of Newcastle Central. This is more what they look like. And what you would actually have, we kind of come over, don't care about it being broken, but whatever. They would sit something like this on the end of the station. So you would have one there, you would have another one here, obviously facing the other way, you would have them up there, you'd have them dotted around at the end of each of the platforms, something like that. So those route indicators were kind of important. So I went ahead and did that, and it's important to note that this process was probably no more than about 2 hours. So from the initial design, that took, I don't know, 20-30 minutes on the computer, learning how to do it and figuring out sizing and getting what I thought were the right scales, and then going through and increasing it, and each print was taking maybe 4 or 5 minutes to print these out. So that worked great, and so we ended up with this. But when I actually put it on the layout, it seems small. What's great about 3D printing is you can then just scale it up. So size wise, you can see the difference. This is about 20% larger. Again, it's still got that theater indicator, and now it starts to look overall just a little bit more structured. The ladder isn't great. This was just, again, a quick prototype. I don't think I had done a raft on it. Now when we put this there, now it looks more to size. You could just get a train that could go under it if it was that. So this is much more to size. It's not absolutely perfect, although actually the theater indicator, I'm completely blanking on the name, Industry Dorman, Minute Dorman, something like that. It is actually one of the manufacturers of route indicators. I did get the dimensions online. So the theater indicator is pretty much to scale, and so then most everything else has come off of that. So much happy with that. But again, in general, this idea of rapid prototyping with the 3D printer, in total, this probably took 2.5 hours, 3 hours maybe in total, in terms of designing this out, printing them, assembling this, realizing it was wrong, doing another one that was more to scale, assembling and realizing that, yeah, that's right. And so just to kind of contrast, my original plan from months ago was to build them out of styrene strips. So the idea is that these would replicate girders once they were sprayed and painted. And so you would have, if I can try and do it, you would have the two of them that were kind of stood up like that. Then you would have the platform together, and I would had just regular strips that weren't these kind of these H pieces. They were just regular flat strips that would then be kind of the side supports. And so functionally, that's exactly what this is. But this looks much more prototypical. I think that the scale on this is that the steel girder for the uprights would be about 8 inches, I believe, something like that. But just in general, that looks a lot more realistic in terms of how thick it would be. This would be incredibly thick. This would be 2 feet almost. But I couldn't really find much smaller styrene that I could really work with that was still strong enough to glue. So again, this is why 3D printing has really kind of completely changed my outlook on modeling and has really re-inspired me. I was kind of losing an awful lot of interest beforehand, just not being able to design and really scratch build out what I needed. It probably took me almost as long to figure out measurements on this and cut it and glue it and find the different bits of styrene and width for the ones that I needed to show up in the mail from eBay and Amazon and wherever else, as opposed to I just design this out on a computer, literally click print, and 20-30 minutes later I've then got this. I can glue it perfectly to scale. So then my idea with the signal lights, here's one of the 2-headed signal lights. And so hopefully it will come down to just 3 if I can run it off a common ground that I'm trying. I couldn't get this working before, but I'm going to do something a little bit different this time. So common ground, and then just the red and green for the 2 signals. For now, like I say, I'm not going to do any kind of illumination on the theater indicator. I may change that. I don't think it will be that hard just to drill slightly inside of it, but theater indicator would mean I would then have to figure out exactly what each of the routes would want to look like, and that starts to get a little bit more complicated, I think, at least for what I'm wanting to kind of showcase. Just having them there adds a little bit of visualization, and I think they'll look pretty good once they're spread up and in place. Now, another last thing, again, just while we're waiting for that other 3D print to finish, I also found a whole bunch of these line side relay boxes. There's a 3D design online already. So in the same way that I have shared out the design for the signal gantries that I've put together, someone has already gone ahead and designed these. So there's just the two, that kind of thicker 2-door, and then the narrower 1-door version. But I printed out, I don't know what I've got, 10 10 pairs maybe, and that took 20 minutes maybe, something like that. Used very, very little of that PLA filament. Those could print without any kind of raft. They're pretty solid. But I think that they look really, really good. The detailing on them, it's kind of hard to see in the lighting, but it's got door hinges, and it's got a little bit of rivets and stuff like that. So the detailing on them is incredible. So if we come over and look, I've been using the Bachman branch line set of relay boxes, and these come pre-assembled, they come pre-painted and weathered, and they've got the kind of warning decal on them, and they do look really, really good, but they're expensive. I think it was £6 or £7 for this. What do you get, 3 pairs of those? Maybe it's only 2 pair, or something like that. And so I've got a few of these in place. I got them there, and I've got them kind of hanging out in various different points around the layout, but they are expensive, and really every single one of these signal gantries should have at the least one of those just kind of hanging out, something like that. And I have enough of these, and I could easily add in another one, but I think that starts to get too much. But it means that for every single signal gantry I can now print out one of these, and I have printed out one of these relay boxes to go with it. And again, just in terms of the visual interest that adds, I think that's really going to set it off. So yeah, this whole 3D printing, the investment up front that I made on the 3D printer, in terms of, okay, I've now been able to essentially do 4 or 5 sets of those Bachman branch line relay boxes at £6 a piece, and I've now been able to do these signal gantries. So it's just like, okay, you would have to take out the Transect actual signaling and wiring, but if I was to try and buy a signal gantry like that, it would probably be at least £3 if I could find a kit that could do it, something like that. So I can do 10 of those, which is what I'll end up with, just to the south side of the station. And so for only 3 hours worth of work designing and prototyping, and then letting it print for an hour and a half to do a set of 3, I'm pretty much already at 60-70 pounds worth of equipment here, just from that one run of the 3D printer. So I've still got the north side of the station to do, I've still got some of the columns to do, I've still got benching and things like that. So overall definitely happy with that investment in the 3D printer. Yes, I have no idea how well this is going to work in terms of trying to show this going together, but these are the parts that you end up with for one individual set of signal gantries. For disclosure, these ladders are a little bit longer than they probably need to be, so I actually cut off, I think it's 4 rungs of this, just because that's the angle that I want to create. But it's designed so that it could be kind of whatever angle that you would like it to be. I found that about 4 rungs off is pretty much where I want to go. In terms of gluing it, I use Loctite, the super glue gel control. I find that works really, really well for gluing PLA. You can also get some kind of welding glue that essentially melts the plastic together, but this works well. So you take one of the upright gantry supports, narrow part, the narrow part, short part will go on the bottom like that, so the larger opening is going to be at the top, and because of the little notches that are in there, this will almost just push fit. So what you can do, just to make sure you're starting out, just make sure that it fits and there's nothing that you need to trim. You should be fine. The advantage of the gel glue is that it won't really run when you attach it. thin fits. One of the reasons why I like this particular cutting board is that it has squares in place, so it's somewhat easy to be able to line it up and kind of make it square. Then for the then guardrails, there's 3 guardrails that you end up with. One is slightly longer than the other. I don't know how all that focuses in. But one is slightly longer than the other. So the longer one is going to go essentially on your backside, and it will end up in the corner. Part that's then missing one side wrong will then be for one edge, and this will buttress up against where the signal light will be. And then the other one, that's kind of an individual one, that's going to go on the edge pretty much like that. So you do have a little bit of a gap. If you look at one of the complete ones, let me go grab one. This is one of the complete ones. Ooh, focus out a little bit. So you do end up with a little bit of a gap right there. You see you've got one that ends up across the uprights. This is the one on the other side that was missing. It's one upright, and then that longer one goes on the back. And as you can see, my ladder is, I don't know what that is, 30 degrees, 35 degrees maybe. I don't know if that falls within health and safety standards of modern day, but from eyeballing it, that's about what I think works out pretty good. So I'm going to let that dry just a little bit. It then does get a little bit fiddly trying to glue these, so I'll probably end up doing a little bit of a time lapse, speed up the motion part, so you can see that trying to go together with as minimal swearing as possible on my behalf. So it's actually easy to get a little bit of a production line going rather than trying to do one at a time. And excuse me, I'm not sure how much you're really getting from the shadows in my hands blocking the way, trying to get very fiddly putting on those guardrails. So this is what they end up looking like. It should be fairly obvious. The one that we had been doing is the one all the way back here. They've also gone ahead and put on the step ladder for that one. The others don't have them in place just yet. They're just drying up here. I found that this little plastic tub that I use as a paint pot works at just the right height for the lip to be able to hold these up at 90 degrees to be able to do it. You will notice that there's a little bit of a different orientation. So the ones that, this one that we had started out with, the first one and then the one either side of it, they're designed that they would go on a platform with the overhang right. And then the other ones on this side would be on the other side of the station, so that you'd have the light out here, just so that depending on the orientation of the train, so we try and keep in mind this one would face right, this one would face left. So if we came onto a platform here, this is the one that would face right, that's the one that would then face left. So that's also why the platform, the actual platform bases themselves, so this part here, the top part where the light and the route indicator sits, that's why I didn't cut any kind of notches into them to be able to take those guardrails, or for things like the actual cabling, the wiring that will come out the bottom of the signal lights. Just because the design that they could work in either orientation. If I was to do a redesign, maybe I would make different bases for right or left. Not entirely sure, but this is a little bit fiddly, but I think honestly trying to put notches in place would have either looked a little unsightly or would have weakened the structure, because these are so small and so thin anyway. So it's one of those where you just kind of have to deal with it. Even the Transect Signals, trying to put the guardrails on, if you haven't done that, are an absolute pain. I haven't really found any signals where you get such small guardrails where it doesn't become painful. So I'm going to let those glue. We'll go and look inside, because I think that 3D print job is starting to come along now, and we'll see what it looks like as these start to get printed up. So we're back to fan noise, and it is a little bit louder now because there are some other fans that kick on once these are going, but this is what it looks like as it's printing those out. So the stuff in between, if we can try and get around, the stuff in between that looks like kind of crisscross honeycomb, that's the raft that it was starting to print out earlier on. As you can see, that kind of wraps around all the pieces, so it's it was a little bit wasteful, but it is laid out to try and minimize the amount of waste, and I feel like it's worthwhile in terms of what you then end up with as the final product. It doesn't really break when you try and get them out. It does it pretty strong, and it makes them pretty smooth. There's not a whole lot of cleanup. Maybe around the ladders. That's pretty much it. Again, if you haven't seen a 3D printer trying to move around, underneath there, it's kind of going. How low can we come down now? You can see the brass head that's moving around on the right hand corner there. That's where that filament is being extruded from. Very, very narrow line of filament that gets extruded out, pressed into the plate, and it runs, I think I've got this set at 200 degrees Celsius, something like that. Could be Fahrenheit, sorry. As it's coming out there, the fans that are on the front and on the side are then partly to help cool the actual machinery itself, but it's also designed to then cool the filament when it hits the filament bed. So it comes out pretty darn hot, but then cools down almost right away. We're just looking at this a little bit, the filament that's kind of moved around a little bit there, but that's okay. We can easily clean that up on the hobby blades, but this is how it ends up, just printing it through layer by layer, and so it builds it up into these different sections that we've been cutting out. So there's another 10 minutes or so, maybe, I think, of this, 10-15 minutes, maybe it's not quite, before this one is all done, and then we'll be able to let it cool just for a couple of minutes, peel it off, and then we can start to go ahead and glue this final set of signal gantries. So depending on what 3D printer you've got, it might look a little bit different when it's on the print bed. There's different print beds, you can get different materials. Some of these are glass. Don't want to touch it because this runs about 60 degrees as well. This is a heated print bed, again, just to help with adhesion. So depending on what 3D printer you have, it might look a little bit different. The raft may look a little different when it prints out, although it should be fairly consistent. And I'll post in the Thingiverse online and in the YouTube notes here at exactly what the print settings are. I think it's pretty fine at 0.1 millimeter. I think the raft spacing is in 3 millimeters around the side of the model. Filaments at 200 degrees for PLA. The bed is at 60 degrees if you've got a heated bed available. But I'll post the Cura settings that I used to then put all this. But again, it's one way, just through trial and error. Slightly different 3D printer, you might have slightly different print settings than I'm running here. But this is what I found that works fairly reliably for me, and hopefully it's of some use if you want to try and do this yourself. This is that print job just wrapping up, and so when it's done, it kind of moves the extruder off to the side and then slides out the build plate to the front. So this is what we end up with. So it does look pretty good, and again, just having that raft in place means that each of these pieces will come off pretty quickly. Just a little bit of cleanup work to do around one of the guardrails, and then probably just a little bit just comes off that last part of the extruder. Just a little bit of then cleanup around the ladders. I've had that on all of them, just on one side. I'm not entirely sure why, but it always seems to be that right hand side. Need a little bit of cleanup, but it just takes a few seconds. Just going to let this cool for just a minute or two. That's pretty much all it needs. And then I'll pop these off, and then I'll run off another print job to print out the theater indicators. I have those as a separate file. I never bothered adding them to these, but you know, I guess the idea is that if you want to add the theater indicators, you could. If you don't, then you can print them separately. I was just kind of lazy and I left mine separate, but there's no reason why you couldn't bundle it together with this and then print off the entire set as you would need it. So this is in those route indicators all printed up, a little rotated around, so it's kind of hard to get an angle on them, but That's all 9 of them done to go up with 9 sets of gantries that we built. So I'll let those cool just for another couple of minutes, peel them off, and then we can go ahead and assemble those last 3 that we just printed, and then get these theater indicators attached onto all of those too. So then one last thing just to add in here that I did, these are going to be bases for those gantry signals. As I was spraying them up and being gluing them together, I realized that they were going to be kind of having a tough time standing up, which is something that I thought of earlier, just didn't go ahead and done it, but these are going to just get spread up as a grey, concrete grey almost, a little bit of weathering, and then each of the signal gantries should just slot into those 2 legs and give it a little bit more stability. It's still going to be able to stand up by itself because it's always going to be heavy on one side, you know, because the gantry leans over to the right or to the left, but this should hopefully at least give some way for the signal gantries to be able to get glued down onto the station platform or along the line side ballasting, something like that. Then one of the signal heads completed, I went ahead and then spread them up with a grey primer and then somewhat of a metallic silver. Attached in the signal heads as well. I didn't cut a hole on the top of the platforms intentionally because I wasn't entirely sure exactly what diameter wire I would need, or if other people were going to use it, or why they would need. So I just then very carefully, well, somewhat carefully, drilled a hole through the top, fed the wires through, and then I've just kind of glued them in place so they wrap down like that. The idea is that they would then hide in behind the back of that relay box. Also then went over a little bit, and it looks a little bit odd on the camera now, but it's really not that bad in person. Went over a little bit with some of the Humbrol weathering powders for rust and for, I think it was a dark earth as well. And a black pen on the cabling. It's just drying off a little bit. So you could finish these up pretty much however you want. This is the way I decided to go ahead and do it, and so I think that like that with the 2 aspect signal head and that theater route indicator, that'll look pretty good. So I've already got a hole drilled there in the baseboard, so I'm going to try and get this fitted up and then see if it'll work. So this is now that signal gantry installed on the layout. It's hooked up just so that you can get, just make sure that the signals are actually working. One tip from doing some of these signal heads before is both to make sure that the actual LEDs work on a power supply before you try putting them into the signal head and then soldering up the wires, and also then to make sure that they still work after you've put it in place and soldered those before you attach them to the signal gantry. When I was doing the overhead signal gantries for the main lines, kind of ran into that, and it was a little frustrating to have to then try and back it out. And I did find that at least with the 2 aspect signal kits and LEDs that I went with, they were just super duper cheap off of Amazon. So I did find that 2 or 3 out of, I guess, the 20 or so that I got of the red LEDs didn't actually work. But I got to test those out first, and so it's actually worked first time. So I don't have any sensors hooked up into the track right now, so we're just assuming that 47001 is hanging out right there on a red signal. I've got Imperial class 37 or 49. That's probably pulling through some coal hoppers. So this class 47 is just kind of hanging out on that red signal, assuming that Imperial will be moving on. And this is like I said, the first one of those in place now. A little unhappy with how one of the railings on the back turned out. I'll probably need to go back and trim that because it's not quite all square, but otherwise I think when that's in place with a little bit of weathering that's on there, worked out really well to be able to find those 3D relay boxes, because I think that really adds something as well. I think if it was just the cabling running down, it would look a little bit bare. So what I probably now need to figure out is a little bit more cable trunking as well, at least to come out to this signal. I think around the platforms I would be okay, you know, because functionally they would just go down into the concrete platforms and they would have the power there. So I think I would be okay there. But for things like this where we've got one, we kind of back out a little bit and see where we're at. This is on the south side, so this would be what would be the freight bypass where 47001's kind of parked out. I probably need to bring out some kind of trunking there. The ones for the platforms that I was talking about, where I've got them just kind of face down and hanging out, I think that probably is okay as they are. So this has been a little bit of a whirlwind, but hopefully it shows how you can go ahead and do 3D printing of those signal gantries. I'll upload them to Thingiverse, and I'll also post a link in the notes here for the video as to how to go ahead and get those. Do try it out if you have access to a 3D printer. Let me know what you think. This has been my first time designing something from scratch, so it's probably not perfect, but it's good enough for what I want. I could probably have done things like ironing on some of the actual parts just to smooth it out a little bit, but overall pretty happy with how this has turned out, because when you back up from a distance like that, you know, you really can't see that it's not super duper perfect. And so I think that overall, you know, once we then get a whole bunch of these other signals put in place and all wired up, I think this is really going to bring alive Newcastle Central. So thanks for watching, thanks for following along. Let me know what you think, and we'll be back again pretty soon, hopefully with a bunch more of these wired up, and maybe with some of the sensors in place too. Take care. Bye bye.